This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 4 of Vector Basics, and in this video we're going to figure out what the formula for the magnitude of a vector is. So let's say we have a vector AB, so these are just two numbers. And we did this in the previous two videos, but we didn't have any formula. So we're going to think about how we did it for some other vectors and then come up with a formula. So let's look at this vector v. Let's say it's 3, 4. So we could put it any place in the plane, but to make it simple, I'm just going to go ahead and have it start here at the origin. So I would go over 3 and up 4, right? And I could draw my vector. Okay, so that's one place where v could be. And if I wanted to find its length, all I do is make a right triangle out of it, and I see there's 3 spaces here and 4 spaces here. And if I let that be c, I could use the Pythagorean Theorem. So how do we do that? We would say c squared is 3 squared plus 4 squared, right? I'm just going to leave it like that and not simplify it. So the length, c, would be the square root of 3 squared plus 4 squared. Now c is this magnitude that we're looking for, right? So we're looking for the magnitude of vector v. And notice we got the square root, right, of this value squared plus that value squared. So it looks like maybe that's one way we're going to get it. Well, what if we would have had this a different vector? How about if it was negative 3, 4? So let's say we had a vector w, negative 3, 4. So let's see, where would that be on this same picture here? I would just go over negative 3 and up 4, and I would get that vector. So let me label these a little bit better. Let's take off these numbers for the moment, and this is actually vector v. Okay, this actually is vector w. They're exactly the same length. But to get the lengths, notice I would be doing the same thing. This is 3 and this is 4, right? So this actual length here is 3 spaces and this is really 4 spaces. Okay, so if I were trying to find out the magnitude of vector w, it's still going to be, well, what would I do? I would do 3 squared plus 4 squared and take the square root. It looks exactly the same. Are you with me here? But, well, I've got 3 squared. I don't have negative 3 squared, right? So that idea of just taking that number and square it, it doesn't look exactly the same until you think about something. Well, when you square 3, it is the same thing as squaring negative 3. So if it's a negative number, you square it, and you get the same thing as if it was a positive number. So notice this 3 squared, you end up really taking the absolute value of that number. So even though you went to the left 3 spaces, right, you're really thinking about the absolute value of what that is when I just use the Pythagorean theorem, not using a formula. And then what I noticed, that would have been the same as if I had left it as negative 3 and went ahead and squared it. I would still get the square root of 9 plus 16, which is square root of 25. So both of these vectors, right, they're different vectors. V and W are different vectors, but they have the same length, they have the same magnitude. So the magnitude of each is 5, right? So here we are. What if you have some vector and its components are AB its magnitude. And just keep in mind, remember what I said, some people just write it like this. It depends what book, what teacher, what country you're in, etc. The magnitude is the square root of a squared plus b squared. That comes directly from the Pythagorean theorem. You don't have to worry about whether a or b are negative because when you square it, you end up getting a positive number anyway. And there we go with the magnitude of a vector. Let's do one problem. All right, so if you're asked to find the magnitude of this vector, well, you could draw a picture of it. That is perfectly fine, or you could use the formula. The magnitude is, that means the length of the vector is just the square root of a negative 1 squared plus a negative 5 squared. If you want to use the formula we just came up with, which is 1 plus 25 underneath the square root, which is the square root of 26. And that is our answer. Now, did I have to put negative 1 in here and negative 5? Not really, because you know it's going to be positive. If you want to put in 1 squared plus 5 squared, you will get the same answer. So in other words, if you want to think of it as, if you want to think about just the Pythagorean theorem, you don't really deal with those negatives, right? So if I look at this vector, negative 1, negative 5, it's right here, right? That's one way of drawing vector W. And if I just put the lengths here, that's only 5 units and that's 1 unit. And you thought of that as finding that length C, you would have written C squared, you would have written C squared as 5 squared plus 1 squared, and you would have written C squared as 26, 25 plus 1, C is square root of 26. So you don't have to memorize the formula at all. You could draw a picture and use Pythagorean theorem each time, or you could use the formula and just take each component, square it, and add it together. Or you could think about what would happen if you didn't put the minus sign in. It really wouldn't change the final answer because you're going to square it. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.